What's up? What's up? It's your man Jimmy Chan. So today we're talking about measures of dispersion. All right. So we're talking about anywhere from about the range, about variance, about standard deviations. All right. So first, let's talk about range. Range is just the difference between the largest and smallest value. So the range here, if we took the example that we did before, we just take the highest value, which as you look is going to be 94, minus the smallest value, which I believe is 62. So let me go ahead and highlight those two. And it gives me a chance to double check to make sure it is 94 and to double check that it is 62. Right? I don't see anything less than 62. I don't see anything larger than 94. So that would be my range. And that is going to be a, what is that, 32? Okay. Let me double check that as well. So 94 minus 62 is a 32. So that would be my range. All right. So let's talk about standard deviation. Now, just like mean, the standard deviation has a population standard deviation, right? Which is denoted by sigma. This is sigma, okay? And the population variance is sigma squared. So when you find one, you have found the other. All right. Now notice that the n is still the big N is still the same, right? The number of observations is still considered capital N, right? So we're still going to be using the mu for the average, which is necessary. All right. However, when you look at the sample, oops, I'm not going to use that. I'm using blue. The sample standard deviation is just S. Okay, the letter S. And the sample variance is S squared. So similarly, we're still, if we get one, we can get to the other. The biggest difference here, guys, is that we are going to be having a different denominator here, which is an n minus 1. All right, which is, they call it degrees of freedom. All right, so what it is saying is that when we're dealing with a population, we know all the results. So when we find the standard deviation, that is the standard deviation, right, of all those observations. Where the n minus 1 is more of saying, because we're sampling, we don't know what that next sample coming in is to confirm that we have a solid. We don't know where that observation is going to take us. So we have n minus 1 degrees of freedom, right? Because that last one that we pick is not necessarily free. It might really hurt our standard deviation / variance as we go. All right. So what I'm showing here also, and notice that it's using X bar, okay, which is again a sample mean, right? So when you guys look at here, what I did was, anytime we are looking for standard deviation or the variance, we're going to actually create a table, right? Where essentially I want to get a chance to get this part all set up. And I don't know why that says X bar, because that should not be X bar. That should actually be mu. So let me go ahead and put a big fat circle here, and I'm going to go ahead and tell it to fill with white. But that should be a mu. Okay, so I am trying to get this part into a table. Okay, so that's what I want to do. So that's the reason why I have the X sub I, which is I would list out all of the observations. I would find their mean, and yes, this column is going to literally be the same exact numbers over and over and over again. And now I'll subtract the two columns to get this, which is what is inside this parentheses. After I subtract it, I'm going to go ahead and take that number and square it. And then on the bottom of this column right here, I'm going to add all of those numbers so that I have the sum of that column. Then I would divide it by n, and that will give me the variance. And then if I take the square root, then I'll have the standard deviation. Similarly, with the sample standard deviation, I would do exactly the same thing with the table because I still need the same thing here, okay? The only difference is that when I sum up this column, I'm going to divide by n minus 1, okay? So let's take a look at what the next page gives us because we're going to go into that example, right? As you can see, I have my x of I. So I listed all 10 of those test scores, right? Because this is a population because there's only 10 students in this class. The population mean was 79, which we got before. So again, the same number over and over. Then I subtract these two columns as is, right? 82 minus 79, 77 minus 79, 90 minus 79, 71 minus 79, right? So there's going to be a positive and negative numbers as we go. And if I sum up this column, it's always going to give me 0. Always going to give me 0. But now here on this fourth column here, I'm going to square this column. So I'm going to take the 3 square, negative 2 square, 11 square, negative 8 square, negative 17 square, and so on. And I'm going to add them up together. And here is the sum of that column. Again, I have 10 scores, right? So in this case, my variance is going to equal to the sum, right? Because let me go ahead and write this down. Is the sum of x sub I minus mu squared divided by 10 in this case, or I should say n, right? So that means this is going to equal to the 964 divided by 10. So my variance is going to be a 96.4, right? So that is variance. So this is variance. So now for me to find my standard deviation, let me go ahead and copy this over and bring it down. Actually, you know what? Let's just bring this whole thing down. This way there's more space down here anyways, right? So I know I can do that. So that is my variance. Actually, I don't need that part anymore. So to find my standard deviation, which is just sigma, that is going to be the square root of that 96.4. So this is going to equal to 9.82. And this would be my standard deviation. Okay? And my population standard deviation at that. Okay? So that's how we would go about doing it. Making a table is kind of a pain. Yes. Chances are if I want you guys to do it by hand, it'll be about 10 observations, right? However, if I wanted you guys to do more like 50, I'll probably show you guys how to do it on the calculator. All right, so let's move on from here. And now here, there's some talks of the degrees of freedom. So now you guys can kind of read about it a little bit. All right, so let's move on to the empirical rule. So this is saying from one standard deviation away from the mean, it lies 68% of the data. 2 standard deviations away is 95%, and 3 standard deviations away is 99.7% of the data. And you're like, huh? Because this sounds like lawyer talk right now, right? So let's go ahead and show it to you in picture form. So this is much better, right? I prefer the picture form for sure over, oopsies, over the so-called word form. Hey, what's going on? Okay. That's why. Gotcha. All right, so let's take a look. So it was saying that, so when we have a so-called bell-shaped curve, okay, what we have is that the mean and the median is in the center. They are equal to each other in the center. So what I just found there was standard deviation. Well, one standard deviation away, so with that example, this would have been 79 because that was the population mean. And the standard deviation was what, 99.8? So 9.82, let's say 9.8. So this would be 79 plus 9.8, and it would have been giving me 88.8. And if I took that 79 and subtract the 9.8, I'll get 69.2. Okay? So to get that, so let me go ahead and put this in parentheses. This was 79 minus 9.8, and this was 79 plus 9.8. And that's what this part means, right? Add the sigma and subtract 1 sigma, okay? So what it's saying is that 68% of the data would lie between here, between 69.2 and 88.8. 68% of the data would be that. So I would tell you to think of this as area under the curve. And since this is 68 and this is symmetrical, that means these two halves would be exactly the same, right? It's not skewed left, skewed right. It is symmetrical. So that's why this is 34 and this is 34. With 2 standard deviations away, that means if I took the 88 and add another 9.8, now I'm going to have a 98.6. So here I took the next, well, essentially what I did was I took 79 and added 2 times 9.8, right? That's what I actually did there. And if I took 69 minus another 9.8, I'll get a 59.4, which really what I did was took the 79 and subtracted 2 of those 9.8s. Isn't that what this is saying? Take the mean minus 2 times the standard deviation. And that's exactly what I did. So let's go ahead and move this over. So I can move this over, okay? This is telling me that 95% of the population would lie between 59.4 and 98.6, which would be 95% of the population. So the way they got these 13.5s is take the 95 minus 68 and then divided it by 2. So again, the 13, let's do this. The 13.5 came from 95 minus 68, which is equal to 27. And then taking that 27, actually, I could actually do it this way. This might be better. Undo. Which will give you the 13.5. Okay. So it's even on both sides because again it's symmetrical, so that's why it's okay. And then with 3 standard deviations away, same thing. I would just take the 79, subtract the 3 standard deviations, and 79 add the 3 standard deviations, and 99.7% will be there. All right. So I hope this helps. If there's any questions, please let me know. See ya. Bye.